Hi all, in this video we're going to take a look at the sum and the difference identities for cosine. So I have them in a nice blue box here. We're not going to go over the proof for these. You can find that in your textbook in section 5.3. So that would be chapter 5.3 in the textbook. And it has a really nice proof for the cosine of a minus b, and the same proof can be used for the cosine of a plus b. Okay, this formula right here for the cosine of a plus b and the cosine of a minus b, cosine of a plus b equals cosine of a, cosine of b minus sine of a, sine of b. It's been proven, it's a fact, it's an identity. Okay, cosine of a minus b equals cosine of a, cosine of b plus sine of a, sine of b. And what I'd like you to notice here is that if this is a plus, this is a minus. If it's a minus, then I have a plus here. But the nice thing about these is that you don't have to memorize these for a test. You're going to be given an identity sheet, and these identities will be on that identity sheet for your test. So you don't have to memorize it. Just memorizing it makes your homework a little bit easier and a little bit faster. But you don't have to memorize it for a test. I really just want you to learn how to use them. And then I'm going to do a brief review of your cofunction identities. This goes and takes us all the way back to chapter 2. Our cofunction identities come from a right triangle, if you remember that. In a right triangle, these two angles here, this angle here and this angle here, must be complementary because the angles of a triangle add up to 180, and when we take this 90-degree angle left, the other two must add up to 90 degrees. So how do I find this measure here? This is 90 degrees minus theta. And if I just label the sides of my triangle as A, B, and C, you can see that the sine of theta equals B over C. And if I take a look at this angle, what trigonometric function for this angle has a value of B over C? Well, that would be adjacent over hypotenuse. So the cosine of 90 degrees minus theta is also B over C. So sine of theta and cosine of 90 degrees minus theta, they must equal the same thing. These were chapter 2 identities. I'm not going to go through all of them. We did that in chapter 2. They should have been memorized then, but we are going to use them in this section. So they do have to be memorized because we've already done these, all right? So let's move on to examples in terms of using our cofunction identities and using our sum and difference formulas for cosine. All right. So in this example, we're just going to go ahead and use our our sum and difference of cosine in order to simplify this a little bit more. Maybe find an exact value or something a little bit simplified than what we have here. But this is not a cosine function. So we're going to use our cofunctions to convert this into cosine, because I know that the sine of an angle equals the cosine. If this is the angle we're looking at, theta, I know that cosine, sine of theta equals cosine of 90 minus theta. And I should really not even use 90 degrees because we have pi over 2 in here, right? So pi over 2, I should replace 90 degrees and use my radian measure here. All right, so if I simplify this, I get the cosine of pi over 2 minus pi over 2 plus x, which just simplifies down to the cosine of x. So that was a nice little example of how to use your cofunction identity to simplify a sine function or another function. Okay, So now let's go ahead and take a look at how we can use our sum and difference formulas for cosines. It says use identities to find an exact value. And we should not be using our calculators in this section. So I don't know the cosine of negative 15 degrees because it's not on my unit circle. But I do know all of these angles on my unit circle. And with my identities, I can find a sum or a difference that would amount to negative 15 degrees. So when I take a look at these, you can use these with positives or negatives in front of all of them because you know that a negative angle is just going around your unit circle backwards. So you can use any positive or negative of these angles that I've written out here. And these are all the angles that we know in degrees on our unit circle. So how can we use these to get the cosine of negative 15 degrees? Well, I know that any two angles that are separated by 15 degrees, when I subtract smaller minus bigger, I'll get negative 15 degrees. So here's just one method that we could use. I could go 30 degrees minus 45 degrees. I could also say, well, let's see, 150 and 135 subtract to 15. So I could say 135 degrees minus 150 degrees. I can also use an addition formula where I say, for instance, the cosine of 30 degrees plus negative 45 degrees. So there's a whole bunch of possibilities that I can use. I'm actually going to just choose this one. I like this one. It's the most simple form. So let's go ahead and use the difference formula. So I know that the cosine of negative 15 degrees equals the cosine of 30 degrees minus 45 degrees. And the formula for this, if this is A and this is B, I get cosine of 30 degrees, cosine of, I need to write it correctly, cosine of 45 degrees, there I go again, cosine of 45 degrees. This is going to be a plus sine of 30 degrees, sine of 45 degrees. And when I simplify that, I know all of those values. The cosine of 30 degrees is radical 3 over 2. 45 degrees is radical 2 over 2. I'm going to add to that the sine of 30, which is a half, and the sine of 45, which is rad 2 over rad 2. And when I multiply them out, I get this answer. And they can't be combined, so this is my exact answer. So I'm not going to write all of these angles out for every single problem, but I am going to try and keep it up here for this one. So the cosine of 105 degrees, well, either I have to find a difference of two angles that equals 105 degrees, or I need to find two angles that add to 105 degrees. So I could use the cosine of 45 degrees plus 60 degrees. What else could I do? I could use, let's see, I could do a difference and say the cosine of 150 degrees minus 45 degrees. Any of these work, okay? And there are other possibilities that we can use as well. But I'm going to do my example using this one. So I know this is going to be the cosine of 45 degrees times the cosine of 60 degrees. Since it's a sum, I'm going to use a minus here. Sine of 45 degrees, sine of 60 degrees. And when I simplify these values, I get radical 2 over 2. Cosine of 60 is a half minus radical 2 over 2. Sine of 60 is radical 3 over 2. So I end up with radical 2 over 4 minus radical 6 over 4. And that is the exact value of the cosine of 105 degrees. You could plug that in your calculator. If you plug cosine of 105 degrees in your calculator and then this, those two values will be equal. So how do we do the same thing using radian measures? Well, here are all my angles on my unit circle. I'm going to put in 2 pi here at the end. we need to either find two that add or subtract to pi over 12. So I know to get 12 in my denominator, I either need to have a 6 and a 4 or a 3 and a 4. So I'm going to try one of these. I'm going to try, since this is not negative, I'm going to do a bigger angle, pi over 4 minus pi over 6, and see if that works. That's 3 pi over 12 minus 2 pi over 12, and that's pi over 12. So I know these two angles work. So I'm going to use pi over 4 minus pi over 6. This happens to be, let's make sure I have, this happens to be 30 degrees, and this happens to be 45 degrees. So any two angles that subtract that has a difference of 15 degrees would work for this one. So I'm going to use pi over 4 and pi over 6. So I have the cosine of pi over 4 minus pi over 6. That'll be the cosine of pi over 4, cosine of pi over 6, minus sine of pi over 4, sine of pi over 6. That gives me radical 2 over 2 times radical 3 over 2 minus radical 2 over 2 times 1/2. And I feel like I've done this problem before, because we probably have, right above this. Okay, so now how would I do something that's negative? Well, if I go back here, all I need is to find two of these, maybe two negative angles that add, or a negative that and one that's I'm subtracting a positive. So I like for 7, I like pi over 4 and pi over 3, because I know one will come out to be 3 over 12, the other one is 4 over 12 if I add those. So let's see, if I do negative pi over 4 minus pi over 3, do I get negative 7 pi over 12? 3 pi over 12 minus 4 pi over 12. And it looks like these two angles will work. I'll do negative pi over 4 and minus pi over 3. We'll use a difference formula. You can add negative pi over 3 if you want to too. So this is going to be negative pi over 4 minus pi over 3. And that's going to come down to the cosine of negative pi over 4, cosine of pi over 3. So now we're going to add here sine of negative pi over 4, sine of pi over 3. And for my negative angle identities, I know that the cosine of a negative angle just equals cosine of pi over 4, cosine of pi over 3, plus, and I know the sine of a negative angle is equivalent to negative sine of pi over 4. So that's going to turn this into a subtraction. Sine of pi over 4, sine of pi over 3. So the cosine of pi over 4 is radical 2 over 2. Cosine of pi over 3 is 1/2 minus radical 2 over 2. Sine is going to be radical 3 over 2. So I get radical 2 over 4 minus radical 6 over 4. And that is my final answer here. My last example for this one is, actually, I'm going to put this example on a different video. So look for my next video.